Hello, my name is Brandon Alfano, and this is my CCT for Calculus and Vectors. The purpose of this video is to provide a step-by-step guide on how to solve the following question on page 295 of the textbook. This question comes from Unit 5, which concerns exponential functions, logarithmic functions, and the rate of change. Without further ado, here is the question. 14. A certain computer that is purchased today depreciates in value according to the function v of t is equal to $900 e to the power of negative t over 3, where t represents time in years. A. What is the purchase price of the computer? B. What is the value after 1 year? C. How long will it take for the computer's value to decrease to half its original value? And D. At what rate will the computer's value be depreciating at this time? As you can see, the question involves the economic relationship between the product's value and the time elapsed. Much like cars, computers can rapidly lose their value over time due to the fact that new parts and models are being released faster than most people can keep up with. The value drops significantly within the first few years, but the rate at which the computer depreciates, drops in values, also drops significantly within those first few years as well. After a long while, the computer will eventually depreciate by small amounts per year, but its value would already be fairly low at that point. This relationship is best modeled with the exponential function, much like the one that was provided in the question. Before we start, let's look at the equation in more detail. The aforementioned equation can be broken down into three distinct parts: the coefficient, the base, and the exponent. The coefficient is essentially a value that acts as a multiplying factor for the term. The base is a number that is being multiplied with itself, and the exponent is a value that determines how many times that the base number is multiplied. In the case of the provided question, $900 is the coefficient, the base is e, and the exponent is negative t over 3. The e is a representation of a mathematical constant known as Euler's constant. It is equal to almost 2.7183. An interesting thing to note about Euler's constant is that the derivative of the equation f of x is equal to e to the power of x is identical to the original function. We'll go over derivatives later in the video. Let's start the question by answering part A. What was the purchase price of the computer? We can easily determine this value by substituting the time for 0, because no time has elapsed at the time of purchase. 0 divided by 3 is still 0, so the exponent is equal to 0. Any power with its exponent is automatically equal to 1, which leaves us with 900 times 1, which also leaves us with the answer of $900 as the purchase price. In this type of question, the coefficient is usually equal to the initial value, so you can always look there for your answer if you want to save a little bit more time. Part B of the question asks us, what is the value after 1 year? We can answer this part using the exact same method that was used in the previous part, but substituting t with 1 instead. By doing so, this makes the exponent equal to negative 1/3, or negative 0.33 repeating. Euler's constant to the exponent of this value is equal to approximately 0.7165. If we multiply that with the coefficient of 900, we will get the final answer of approximately $644.88. Part C of the question is a bit trickier. It asks us how long will it take for the computer to decrease to half its original value. In part A, we discovered that the original value of the computer is 900, so half of that would be 450. Now that we have the value, we can substitute it with v of t and solve for the time that it corresponds with $450. This leaves us with the equation 450 is equal to 900 e to the power of negative t over 3. From there, the goal is to isolate t. In order to do so, we must divide both sides by 900 to get rid of the coefficient on the right side. The result is 0.5 is equal to e to the power of negative t over 3. At this point, you may be wondering, how do we get rid of Euler's constant? The answer to that question is we can do so by applying the natural logarithm to both sides of the equation. The natural logarithm is expressed as ln, and is essentially a logarithmic equation with Euler's constant as its base. This can be used to eliminate Euler's constant from the equation due to the special relationship that exists between exponential functions and logarithmic functions. If you have an exponential function with an exponent that is a logarithmic function with the identical base and x as its input, the entire equation would be equal to the input. If you have a logarithmic function whose input is the same base exponential function with x as its exponent, the result is equal to x. Essentially, the logarithmic and exponential function will cancel each other out, leaving only the remaining input/exponent. The same will occur with ln and e to the power of an exponent. Back to the equation, if we apply ln to both sides of the equation, that would leave us with approximately negative 0.6931 is equal to negative t over 3. Last, we must multiply both sides by negative 3 to get rid of both the denominator and sign. The final result is t equals to 2.079. Therefore, it would take approximately 2.1 years, rounded up, for the computer to decrease to half its original value. You can check your answer by inputting 2.079 into t and solving for v of t using methods outlined in parts A and B. Likewise, you can check the answer that you found in parts A or B by using your final result and putting into v of t and solving for t. In both cases, you know your answer is right if the final result is identical to the number that you substituted in originally. These methods work because solving for parts A and B is essentially solving for part C backwards and vice versa. In order to answer the last part of the question, we must first understand what a derivative is. A derivative is a function that models the instantaneous rate of change of another function. A derivative can be expressed as v prime of x if the original function is v of x. The prime indicates that it is a derivative. Generally, a derivative can be found by multiplying the coefficient by the exponent of the variable and subtracting said exponent by 1. There are additional rules depending on the type of function and the situation. This is the foundation on which calculus is built upon. That being said, let us commence to part D, which asks us at what rate will the computer's value depreciate at this time. The time that is referring to was found in part C of the question, so t would be equal to 2.079. However, before we substitute anything, you must first find the derivative of the provided equation. The derivative of an exponential function with Euler's constant as a base can be described as the derivative of the exponent times the original function. The exponent negative t over 3 can also be expressed as negative 1 over 3 times t. If we multiply negative 1 over 3 by the exponent of t, which is 1, and subtract said exponent by 1, we will have the derivative. T to the exponent of 0 is equal to 1. Therefore, the derivative of this exponent is simply negative 1 over 3. If we follow the aforementioned rules of deriving an Euler's exponential function, we are left with the equation v prime of t is equal to negative 1 over 3 times 900 times e to the power of negative t over 3, or v prime of t is equal to negative 300 e to the power of negative t over 3. Now what we need to do is substitute 2.079 with t. 2.079 divided by negative 3 is equal to negative 0.693. Euler's constant to the exponent of 0.693 is equal to approximately 0.5. That times 300 is negative 150. Therefore, the computer is depreciating at approximately $150 at 2.079 years. Now we are finished answering the question. On a related note, the skills used in answering this question and generally knowing how to find the instantaneous rate of change of an exponential function would be helpful in a plethora of careers. Accounting is one of the most notable ones that utilize these skills. An accountant's duties involve examining and analyzing financial records in order to determine the most efficient ways a company can maximize profits and minimize losses. Sometimes, this part of the job requires them to determine the rate of depreciation regarding certain assets, such as electronic equipment. This would allow them to figure out both the overall cost of keeping said equipment per year and the equipment's residual value. Now you know how to answer an economic calculus question involving exponential functions and a related career path. Thank you for watching, and I hope this helps.